This is my letter tally program. I wanted to make it easier for people to work on maybe decoding different ciphertexts that they may get. And this can be one way that will get you a head start on trying to figure out what the person did to encrypt their plain text. So if you just copy and paste the text into this area, it will automatically count how many of each letter there are. It'll turn it to uppercase and then count each letter and then give you a percentage of the whole entire text that letter shows up in. For a small amount of text, this isn't always the most indicative way of determining what they did to encrypt. But if you were to take a large sample, then you can match it with that language, and in this case, English. So for example, T and E are pretty common. And so if I just take what I wrote up here, we can look and see that T has 12% and E has 15% of the entire text. And so if these letters were switched to K's and L's maybe, or something else, then we could work to decipher and plug those letters in to decipher the text. Here's another example. There are no numbers. So in this case, the 1 is not being represented in here. And you can give it all uppercase as well, and it will show you. And this does reset every time and only show the calculation for what's up here. As I'm looking over this code and then the demo, I realized that during that second test with one FinDog, the percentages didn't reset, they were all 0. And this is because of my total count of characters that didn't get updated, and you'll see that when I look at the code in just a little bit. This is a screenshot of the correct calculations after I made that change and published it to GitHub. For the code side of things, our CSS, pretty simple. We've got our original text box with our width, our max width and height, the frequency output wrapper, give it a border, have a width and a height, the table, which is inside the frequency output wrapper, and then each of the table data elements. In the HTML, we have our header, all that upfront stuff. We have actually this is the header. This is the metadata stuff up here. We have our introduction, just kind of explaining what it does and how to use it. This is our input text area right here. It calls update letter frequency. And then we have the frequency output, and that just is going to be a table of the count on top, the letters, and then the percentages. And then we load up the JS and add the footer. For the JS, we start with creating a letter frequency array. We haven't initialized it, we just declare it. We have our RE, which is our regex for all letters, all uppercase letters. Total letter count. We have our display chart, our display alphabet chart, which gets called on load down here from our tally load. Actually, we call it reset first, and we just reset the letter frequency array. So we reset all of the letters down to a count of 0. We call that a display alphabet chart. We clear out the output, and we have the temp frequency row, temp alphabet, and temp percents. So these are going to be the 3 rows for every letter frequency in the letter frequency array. So we're going to cycle through that array. We are going to look at the letter frequency, so the count we're going to show the alphabet, and we're going to just add that frequency to 65, get the ASCII value, and display that. And then we're going to get the temp percents. So as long as the temp letter count, if it equals 0, then we're just going to give it 0. Otherwise, we're going to do the calculation. Then we're going to display the frequency row, the temp alphabet, and the temp percents. Updating a letter frequency. So this happens every time a new input is done. We reset the letter frequency array, and then we take the original text value. We set it to uppercase first, and then we take in that text, and for every letter of the text, we're going to just make sure that it's an uppercase letter. That's why we don't have our special characters, so periods, commas, greater than, less than signs, spaces, and in the numbers, I think I said. So as long as it's an actual uppercase A through Z, then we will find out which position it's in. So we take that text, char at the letter, get the code, and then subtract 65 from it so that we can get the index of this array. And we're going to increase it, and then we're also going to increase the total letter count. And now that I'm seeing this, we're going to do some on the fly fixes there. And then so that just clears out our total letter count. So then that'll allow us to divide by it up there to get the percents. And then we display the alphabet chart, which again is where we divide by the total letter count to get that percentage. So pretty straightforward. And that is how you can get a start where you might start if you have a ciphertext and you want to get back to the plain text. Thanks for staying with me, and have some fun trying to decode some ciphertext. Like and subscribe.